Welcome, students. In this video we're going to be solving and graphing simple inequalities. I think a couple of them we have to do the distributive property, but other than that they're pretty basic idea. All the rules of solving equations still happen with inequalities. The first thing we have to do is come up with what we call the solution statement, and it'll look like, so to speak, x may be less than or equal to -3. Or sometimes it can be x is less than a -3. And so while I bring this up, a couple of things to remember about inequalities is the idea of what we call closed or open sets. In this first case, where x is less than or equal to a -3, that little bar underneath it means equal to. So it means that I'm looking for all the x's that are smaller than a -3, but I also can include -3. Whereas on the other case, we have what we call an open set, and an open set does not have the equal to bar, so there's no equal to in play. So you can't include the boundary point in this case, which is a -3. So if you have an open set, it'll be a circle. In the first one, we have a closed set. You show it by a colored dot or a colored circle, and then in the open set you show it by a circle, and that circle is not colored in. I kind of call them a Cheerio and a Skittle because one of them is colored in. Okay, let's take a look at our number line here for a second. We're going to talk about what it means to be greater than or less than. So you've got 0, 1, 2, 3, 4, and we'll just go up to 5. And if you look at the numbers, they increase going to the right. So numbers get bigger as they go to the right. So that means if a number is bigger than another number, it has to be the right of another number. It has to be the right of another number. And that makes perfect sense, right? So greater than or equal to always go to the right. So on the other spectrum side of the number line, or being less than, is the fact that numbers to the left of another number will always be smaller. We know that on the number line that the numbers get smaller as we go to the left. So smaller numbers are to the left of another number. So those are the two ideas that we have to keep in mind. What's the idea of greater than or less than, and what's the idea of open and closed? Okay, in problem number 1, you can see that I have 9 subtract x is less than a -10. I need to get that 9, that positive 9, to go to 0, so I either subtract 9, or you can just look like we're think about it as adding a -9 to each side. We know that a positive 9 add a -9 or subtract 9 will go to 0, and that will give me a -1x is less than a -19. Now I get the -19 because my -10 and my -9 are both, they're the same sign, so I add them and keep the sign. Now what's important to remember is that x cannot be negative. It doesn't matter if it's an equation or an equality, that x has always got to be positive. Now to get that to be positive, I'm going to divide a -1 to each side. So I divide a -1 to the left hand side, I divide a -1 to the right hand side, just like if I do it to both sides, just like with an equation. What it causes to happen is there is a sign change to both sides. You see that -x becomes a positive x, and that -19 becomes a positive 19. And because it causes a sign change, you have to change the sign of everything in it. So that less than becomes greater than. And the best way to explain this is by using the number line. So if I look at the number line, I have a -2, -1, 0, 1, and 2. And we know that 2 is greater than 1. It's a true statement because 2 is on the right side of 1, so that means 2 is bigger than 1, which also means it has to be greater than 1. That's the idea of bigger and greater. They're the same idea, right? Now, If I divide by a -1, just like I did with the inequality that we're solving, look what happens to my numbers. There's a sign change that happens. Now, if you look at a -2 and a -1, you can see that a -1 is bigger than a -2 because it's to the right of 2. So that statement that I have, a -2 is greater than a -1, is a false statement, so we have to fix it. It's wrong. And the only way to fix it is to change the direction of the inequality. So when you divide an inequality by a negative number to both sides, you have to change the direction of the inequality. So we started with greater than, and when you divided by that -1, that greater than had to switch to less than. And you always have to remember that. That's an easy mistake to make. So now that we know what our solution set is, we're going to go ahead and graph it. So x is greater than 19. Okay, so let's go ahead and graph it. We know our boundary point is 19, and because it is open, we're going to do it with a circle. Now remember, our boundary point cuts that graph in half, and I'm looking for all the x's that are bigger than 19. Remember, we have to take that idea of bigger being greater than. So that tells us which way we need to shade, and I have to shade to the right of my boundary point. So I'm going to go ahead and shade to the right of my boundary point, and that makes it right. And remember that it is not equal to, so I leave it to be open, so that's why that I use the circle. Okay, on problem number 13, we have to use a distributive property. So we have a -10 times that +3 and a negative times a positive. They're different signs, so it's going to end up with a -10m. Now, if you look at the -10 and the -3, they have the same sign. So when I multiply integers of the same sign, they become positive, and then I have a -10. Now, you look at our inequality, it's less than, so that means it's going to be an open set, and I'll show that by a circle. Okay, the next thing I want to do is to get that +30 to go to 0. So I put it with a -30, it goes to 0, then I do it to the right-hand side, just like I did to the left-hand side. Now our integer math says if I'm adding or subtracting numbers, I add the signs, I add the numbers, and I keep the sign. So now that gives me a -10m is less than or equal to a -40. Now I want to have a positive m. I will divide each side by that -10, and just like we talked about before, because I divide by that -10 to both sides, that inequality is going to become greater than, because I have to switch it. So m will be greater than 4, and so 4 will be my boundary point. And it looks like, remember, it has to be open. That 4 will split my number line in two pieces, a less than and a greater than. And in this case, we have to do greater than, so we will shade to the right, because numbers to the right are always bigger. In other words, they're always greater than. Okay, our last problem is number 17, and again, I have to use the distributive property. 5 times x will give me the 5x, and +5 times a -1 will give me a -5. Now in this case, I have a less than or equal to. That equal to means I'm going to have a closed set, or I'm going to be my boundary point, whatever that boundary point is, it's going to be closed, and I will show that by coloring it in and making a dot. So make sure that we remember that as we do this. Okay, we have to get the -5 to go to 0. I'll add 5 to each side. I add 5 to the -10. Now the -10 is bigger than the +5, so I will go 10 subtract 5, and I'll keep the sign of the bigger 10, because the 10's negative. There's more of those than the negative or the +5. Now that gives me 5x is less than or equal to a -5. Now I'll divide each side by 5, because I want that to be 1x, and we know that 5 divided by 5 will give me that 1, because 5 divided by 5 equals 1. Okay, now let's go ahead and divide the other side by that 5. Now it's important to know that I don't change signs, because if you look at the 5s, they're both positive. So it doesn't change the direction of the inequality. It stays less than. Okay? You see the 5s are positive. They're not negative. That's the only time you change, is when you divide both sides by that negative number. So remember that. That's an easy mistake that you can make. All right, so I end up getting x is less than or equal to a -1. So that means all the x's are going to be left of a -1, because we have less than. Smaller numbers go to the left on a number line. So we have a closed set, so that means I color in that circle, I shade to the left, and then that is the solution for this. And I thank you a lot for watching this, and have a good afternoon.